Leetcode question 1235. Maximum profits in job scheduling. We have n jobs, where every job is scheduled to be done from start time to end time, obtaining a profit of profit I. You are given the start time, end time, and profit arrays. Return the maximum profit you can take, such that there are no two jobs in the subset with overlapping time range. If you choose a job that ends at time x, you will be able to start another job that starts at time x. In the example 1, so we are given the start time, end time, and profit. The output, the maximum profit is 120. The subset is chosen is the first and fourth job from time 1 to 3 and then 3 to 6. In that case, we get a profit of 120. So the idea for solving this problem is to use recursion with memoization. So the first step is we actually need to sort by the start time and end time and then the profit. So basically what we are trying to do is we are trying to create a single array with tuple of start time, end time, and profit, and then we are sort them first by start time and then by end time. For the second step, that's where the recursive function comes in. For the job I, the input should be each job I. So basically for each job I, we have two options. We either take this job or not take this job. If we take this job, then we need to find the next job we can take by considering the non-overlapping time interval. If we don't take this job, then we can immediately consider whether or not we are going to take the next job. And then the return value from this recursive function is just going to be the maximum between the two options. And then we use memoization. Basically, we store the values that we have already computed before in a hash map or Python dictionary. So let's start coding. So first, let's create a jobs. So basically, we create a single array called jobs, and then we sort the jobs by the start time. Alternative way for creating this job is we can actually do it this way. Basically, you are trying to create tuple with start time I, end time I, and profit I for each I in this range, the length of the start time. Since start time, end time, and profit, they all have the same length. The reason why I use this step is this is more like Pythonic way to do that, and it's a little bit faster or more efficient in terms of the computation. And then after we create this, we can sort them. And then let's define our function, recursive function I. Before that, we need to actually specify our memory cache. And then for any recursive function, we need to actually consider the base case. And then since we are using the memoization, so check if the value has been calculated before. If I in cache, so in that case, we can just return cache I. And then we consider base case, that is if I is actually greater than or equal to the length of the start. So let's also calculate this length of the start. So this is the number of jobs. So if I is greater than or equal to n, so in that case we just return 0. Else we can start our recursive call. So basically we consider two options. So option 1, take the job I. And then option 2, not take the job I. So if we take the job I, in that case we need to find the next possible job to take. So basically, if we take job I, we need to find the next possible job to take. In that case, so we first have j equals I plus 1. And then, well, this j is within the index, the range of the index, and also if jobs I, let's say jobs I and the time is greater than jobs j start time, this means okay, if this j is within the index range, but for this job j, the start time is less than the end time of the previous job, which is the job I that we are taking. In that case, because it's overlapping, so we cannot take job I. So we cannot take job j, sorry. We take job I, but if the job I end time overlaps with job j's start time, that means we cannot take job j. So we need to keep increasing j until we find a job j that we can take after job I. So in that case, we keep incrementing job j. And then once we find a possible job j to take, then in this case, the profit, basically the profit for take job, the profit for taking this job. So profit 1, that is just the profit from the job I. So jobs I 2, that's the corresponding profit. And then call this function for job j. And then for option 2, we are not taking job I. So in that case, profit 2 is just jobs, it's just function. We call this function for I plus 1. So in this case, because we did not take job I, so we can immediately consider the job I plus 1. And then in the end, our result is just going to be the max from profit 1 and then profit 2. So in that case, we store them in the cache. So cache I is just the maximum between those two options. And then we just return this cache I. And then in the end, we just call this function for I start as index 0. So basically, this is overall idea for solving this problem. We are using the recursive solution with memoization. Basically, first sort by the start end time, and then we start implementing our recursive function. Basically, there are two options for each job I. We either take it or not take it. And then the maximum between those two options is just our maximum profit. And then we use memoization, so we use a hash map cache to actually store the values we already computed before. And then in the end, we just return this one. So let's run the solution. Okay, this solution is accepted.